Today we're going to talk about rational expressions. A rational expression is the quotient of two polynomials. A rational expression is in simplest form if its numerator and denominator are polynomials and they have no common factors. They write divisors, if I say factors, whatever. So you can simplify a rational expression by factoring and canceling any common factors. Okay. But you can't tell if a rational expression is in simplest form until you factor. So if we look at this first one, x plus 1 over x minus 1, that's already factored and there are no factors in common, so this is already simplified. The second one, though, is a little hard to tell. You'd really have to factor the top first. But as you can see, there are no common factors, so this is also simplified. Let's come over here. This first one is x over x squared, so I could make that 1 over x. In this second one, I could cancel the x minus 3's and just get 3. And in this third one, I'd have to factor, because I can't tell right now whether or not it can be simplified. But it can, because the top and bottom both have an x plus 2. And so the simplified form would be x minus 3 over x minus 1. Okay. There's really not a whole lot more to it than that, except for one problem with the domain. So a rational expression can be simplified, but it has to have the same domain. So for instance, let's look at this one that we just did. When we have x squared minus x minus 6 over x squared plus x minus 2, it factors to this, which of course these cancel, and we end up with x minus 3 over x minus 1. However, in the first original problem, the bottom factored to be x minus 1 and x plus 2. And we learned in the last section that even if this factor cancels, x still can't be negative 2. It's still not part of the domain. So you can only simplify a rational expression if you then say what x can't be. Otherwise, they're not actually equivalent. Because if we look at this, x can't be 1 or negative 2. But if we just look at this, I only see that x can't be 1. I don't see anything about a negative 2. And so then you have to write that there. Okay, so that's what this is saying. You have to exclude negative 2 from the domain because it's not in the domain of the original 1. Okay. Here's another example. So let's look here. The x plus 2's would cancel. So the simplest form would just be x plus 3. But x plus 3's domain is all real numbers, and this thing is definitely not, because x can't be negative 2. So those two expressions are not really equivalent, because they need to have the same domain to be equivalent. So therefore, you'd have to say that x plus 3 is the simplified version of this rational function with the extra part that says, but x can't be negative 2. Okay, so let's just have some practice here. Okay, so what is the simplest form, and state any restrictions on the variable? Okay, so the first thing we're going to do is factor to see if any factors will cancel. So the top factored is x plus 5, x plus 2, and the bottom factored is x minus 5, x plus 2. And so they both have x plus 2 as a factor. So the simplest form is x plus 5 over x minus 5, but you must say what x can't be. So state any restrictions on the variable. So go back to before you canceled. X can't be 5 and x can't be -2. Okay, let's come down here. This one looks a little different. What is the rational expression in simplest form? Okay, well, I have 24 over -6. That can be -4. I have x cubed over x squared. That's x. And then I have y squared over y to the third. So that's a y on the bottom. But I have to state any restrictions on the variable. So go look at the bottom. The variables on the bottom are x and y. So x and y can't be 0. Okay. We have another one. So we're going to factor the top. Factor the bottom. The top will be x plus 4, x minus 2. And the bottom will be x minus 3, x minus 2. And the x minus 2's will cancel. So that will give me a simplest form of x plus 4 over x minus 3. But then you have to list the numbers that x can't be. It can't be 3 and it can't be 2 because those are the numbers that would make the denominator be 0. Okay, let's try this one. The top, I can factor out a 4, and I'm left with 3 minus x. And on the bottom, this is a difference of squares. Now, I hope you remember this little trick from very long ago, but that is that if you have 3 minus x and x minus 3, you can cancel them if you put a minus somewhere. It actually doesn't matter where you put it, but I think it's most convenient on the top. So now this is the simplified version, but remember, you have to say what x can't be. So go look at the denominator before you canceled. X can't be plus or minus 3. Okay, next we're going to talk about multiplying. Multiplying is sort of a misnomer because you're very rarely actually multiplying anything, but okay, so what is the product of these two rational expressions in simplest form? Don't multiply this together. Do you want to get x to the 4th? I didn't think so. So what you want to do is you actually, I know it says multiply, but you actually don't want to do that. So what you want to do is factor everybody who's factorable and just start seeing if things can cancel. You know, imagine you had this. 25 over 2 times 16 over 100, right? Do you want to multiply 16 by 25? I mean, it's not the worst thing in the world, but you can imagine if I change the numbers, it could be bad. Wouldn't it be easier to just say, hey, this is 4 and that's 8? Oh, and then, by the way, that's 2. Did we actually do any multiplication here? No, we didn't. We actually just did division. Okay, so I thought that was a good comparison. So let's take this first one and we'll factor the top because the bottom is only one factor. So to factor the top, I'll get x plus 3 and x minus 2. And then I'll come over here to the second one, and now I'll factor this one. So the top is x minus 5, x plus 5. And the bottom is x plus 3 times x plus 1. Now remember, you can cancel diagonally. So you could cancel this x minus 5 with this one, and this x plus 3 with this one. So now you have x minus 2 times x plus 5 over x plus 1. Now, this is sort of where people divide into two groups. And that is that some books, some people, some teachers, some tests will require you to actually multiply that back together. I mean, after all, the directions did say multiply, didn't they? But lots of people don't require you to do that. So if you get yourself in this situation, just ask whoever is going to be grading it how they want it, because it's pretty hard to know otherwise. Okay, I know like your book says leaving it like this is fine. I tried to help somebody with a similar problem on Khan Academy, and they wanted it like this. So like, what are you going to do? Okay. So don't forget to say, though, what x can't be, no matter which way you're leaving your answer. So x definitely can't be -1 because there's x plus 1 on the bottom. But you got to go back to the very beginning and pick out anybody who was on the bottom. So x can't be 5, because if it can't be 5 in the original problem, it can't be 5 in the answer. And x also can't be -3. And it doesn't matter that it canceled. It still can't be -3. Because if it can't be -3 in the beginning, it can't be -3 at the end. Okay, well, let's look at this one. So the top here just has a GCF of 2. The bottom is x minus 4, x plus 4. This one is x plus 4, x plus 1. And the bottom is x plus 4, x plus 4. A lot of x plus 4s. Okay, so I can cancel, let's see, this x minus 4 with that one. I can cancel this x minus 4 with whatever one of these you want. It doesn't make any difference. Okay, so now for the top, I have a 2, and I have the x plus 1, and then I have 2 x plus 4s. So you do have to write it twice, or, do a little squared. And then after that, don't forget, you have to say what x can't be. So you got to go back and you got to look at any possible denominator here. So x can't be 4, x can't be -4, x can't be -4, x can't be -4. So just plus or minus 4. And if you did have to multiply these together, you would get 2x plus 2 on the top, and you'd get x squared plus 8x plus 16 on the bottom, where x can't be plus or minus 4. Okay. So you just have to remember it's probably better to decide what x can't be after you factor, but before you cancel, just like we did in the last section with domain, right? You don't find domain after you cancel, because then you'll forget somebody. Okay, it is a little bit different when you're dividing, because there's more people you have to worry about. So when you're dividing, right, you multiply by the reciprocal, right? Just like you would when you're dividing fractions, without variables in it. But the difference here is that to find the restriction, so to find those numbers that x can't be, you have to find what x can't be in anybody's denominator. And because you have that fraction, that second fraction that flips, you have to actually look at both the numerator and the denominator of that one. But I'll show you in the problem. So it means you can't just find the restrictions on the denominators, but it's got to be also on the numerator of, I'm actually going to just write here. I think this will be easier for you. The numerator of the second fraction. So the thing you're dividing by. Divisor is not a word that I really use, so. Okay, so what is the quotient? Okay, so really what's happening here is I'm dividing, but in order to divide fractions, of course, I have to multiply by the reciprocal. Okay, now anybody who makes the bottom be 0 here has to be excluded. But once this fraction gets flipped upside down, this denominator also can't have, x can't be whatever is going to make that be 0 also. So you need to look at this denominator this denominator, and this numerator, and any number that would make those three blue things be 0 have to get excluded. The only one who doesn't matter is this guy. He can be anything. So x could be 2 up there. I mean, it might not be 2 for some other reason, but it's not coming from up here. Okay, so let's start by factoring. So the bottom of this first fraction will be x plus 1 times x plus 1. And the top of this one will be x minus 1, x plus 1. And then x, 5, 2, plus, minus. Okay. All right, now let's look around to see if some stuff can cancel. So I have an x plus 1 and an x plus 1. And I have an x minus 2 and a 2 minus x, which I can do as long as I put a negative somewhere. So now that's negative x minus 1 over x plus 1 times x plus 5. It probably wouldn't be left like that, though. So they would probably change this to 1 minus x. Or I should say most math people. Okay. You could also, instead of simplifying it this way, you could also make it x minus 1 over x plus 1, x plus 5, but you could take that negative and just put it right there, even with the fraction bar. So that's another way you could do it. Okay, but of course, don't forget to say what x can't be. So just from the end, I know x can't be negative 1 or negative 5, but remember, that's not the only place I have to look. So let's go looking around. Right here, right? X can't be 2. All right, let's go look even farther. So I need to look at every part of the fraction except for this. So that means that x also can't be positive 1. And that's kind of tricky. That's hard to see. Okay, but you gotta look for it, so. All right, I'm gonna skip a step on this one. So factoring. Okay, so in this step, I'm just going to multiply by the reciprocal and factor all in one step. So I'm going to take this, that is a GCF of 2x, but I'm just going to put the factor form on the top and save myself some writing. And then this factored form then will go on the bottom down here. Okay, so let's look for some canceling. I have the x plus 4s can go. I have the x minus 3s. And I have this x plus 1 and this x plus 1. That was a lot. So I'm just left with 2x over x minus 1. But there are a lot of things x can't be. X can't be negative 4. X can't be 3. X can't be 1 or negative 1. X can't be 3, but I already had that. And x can't be 0. That's a tricky one. Okay, let's look here. Without doing the calculation, what is the greatest number of restrictions the quotient could have? Explain. Okay, well, I need to look at this denominator, and I need to look at this entire fraction. So that could have two numbers that x can't be. That could have two numbers that x can't be. And so could that. So I think that's a total of 6. There could be as many as 6 restrictions. But of course, if some of these factors cancel, then you won't have as many because some of them will be repeated. Okay. So we have some practice problems down here. This is just simplify and state the restrictions. So greatest common factor of 4. Now I can simplify the numbers, but I can't simplify these. So that's just going to be a z minus 3 on the top and a 2 times z plus 3 on the bottom. But don't forget that you have to say what x can't be, except for that it's not x this time, it's z. Whoops. I bet I did that wrong here. Sure did. Okay. All right, let's try this one. This has a GCF of 3, so that's x minus 1. This has a GCF of x. Cross that out. So the simplified form is 3 over x. But what can't x be? It can't be 0, and it can't be 1. Okay. All right. Now here they're asking us to multiply these two. So I'm going to factor the top. I need two numbers of times to get 12 and subtract to get 4. So that's going to be 6 and 2 plus 6 minus 2. They want me to multiply. And this one has a GCF of 3. Okay, start crossing people out. X minus 2's, the x plus 6's. Now, who can't x be? So you need to look at all the denominators. Negative 6, positive 2, negative 3. And remember, you could also write this as 3x plus 15 over x plus 3. Oops, that one should be a plus, sorry. Okay, last one. Now we're dividing. So I don't know why they did that and they didn't just like put the symbol there, but whatever. So I'm going to factor this top. X minus 5, x minus 2. This bottom, x minus 5, x minus 3. But I'm going to flip this and factor at the same time. So this will be, let's see, x plus 6, x minus 3. And then this will be 2 minus x, 2 plus x. Oops, that kind of looks like a z, so let's make that a 2. All right, let's look for some canceling. I have these x minus 5's. I have these x minus 3's. And I have x minus 2 and 2 minus x, so I can cancel those if I put a minus somewhere. I tend to put the minus on the top. It doesn't actually matter, but I tend to put it on the top. So we have negative x plus 6 over 2 plus x, but I just think that looks weird, so I'm going to write x plus 2, although it doesn't really matter. But again, they probably would not leave it like this. It wouldn't really make sense to distribute the negative because that doesn't make it look any better. But what would look better is this. And those are equivalent. That's just the same as saying like negative 3/5 or negative 3/5. You know, like that's the same thing. Okay. Not our problem. Okay. So now you have to say what x can't be. So there's a lot of things that x can't be. So you can look at the factored form and look at everybody here, here, and here. So everybody but the top left. So that's going to be x can't be 5, x can't be 3, x can't be negative 6, x can't be 3, but we already have that on the list. X can't be 2, and x can't be negative 2. So that was a lot. plus or minus 2, 3, 5, negative 6. Okay, just double checking. So that's really it. I think this section is kind of shockingly easy, but hey, it's the end of the year, so good for you. So do the homework problems, and I'll see you next time with questions.